Hello, welcome to Lesson 7 in our third unit in AP Calculus. Today we're going to be talking about the derivatives of inverse functions. First, let's make sure we remember, that is, what an inverse is. A function g is the inverse of a function f if and only if f of g of x is equal to x and g of f of x equal to x for all their x's in their domain. The inverse of f is typically denoted f inverse with this -1. And it doesn't mean -1 power, it's the inverse symbol. So the properties of the inverse is that if g is the inverse of f, then f is the inverse of g. The domain of f inverse is the range of f, and the range of f inverse is the domain of f. Not every function has an inverse, but if it does, it's unique. The graphs of f and f inverse are symmetric across the line y equals x, and the x and y coordinates of f and f inverse are reversed. So with the symmetry that we're talking about here of the line y equals x, if I were to draw the line y equals x, if I had a function f, let's say that f looks something like this. And in order to have an inverse, it has to be a one-to-one function, which means it has to pass the horizontal line test, which I think this does. Then there are going to be reflections across the line y equals x. So, hopefully close enough that you can get the idea that those would be inverses if they were reflections across the line y equals x. And that reflection occurs because we're swapping the values of y and x. So, for example, let's say we have the graph of f of x equals the square root of x minus 1. Let's find the inverse of f. Well, the inverse of f we can find by switching the x and y values. So f of x is a y. So I'll replace f of x with x, and I'll replace x with y, and I'll simply solve for y. So I'll square both sides, and I get x squared equals y minus 1. So x squared is equal to x squared plus 1 is equal to y. But in order for this to be a true inverse of the square root of x minus 1, we need to restrict this domain a little bit. So recall that the range of f is the domain of f inverse. Well, the range of this is 0 to infinity because you can't have negative numbers as a result for square root. So we're going to have to say that f inverse, I'll just write here, f inverse of x is equal to x squared plus 1 with the requirement that x is greater than or equal to 0. All right, let's graph these two functions. So f of x equals the square root of x minus 1. It's a square root function, but it's shifted 1 to the right. So I'll just move it over here, and the square root goes up 1 over 1 and then kind of makes this sideways parabola. X squared plus 1 would be here, and if we're only doing positives, it'd be like that. And that's how the two graphs are related. The relationship between these two graphs, we can say, is they are reflections across the line y equals x. And we've already kind of done this, but the domain of f, you can't square root a negative because it's non-real. So we're going to say the domain of f, and I'll use inequality, is x is greater than or equal to 1. And the range of f is y is greater than or equal to 0. Well, then that means that my domain of f inverse, the domain of f inverse would be x is greater than or equal to 0, and my range of f inverse would be y is greater than or equal to 1. And you can see from the graph that that certainly is the case. All right, so what I'd like you to do is just kind of go through a little exploration for me about how these two things relate in calculus. So if you would please go ahead and pause the video and do your best to calculate these and answer question F, which is kind of leading you towards a conclusion. All right, let's go over what you should have gotten for your values here. So f of 2, what is f of 2? Well, f of 2 would be simply 2 cubed, which we can say is 8. All right, letter B, f prime of 2. Well, let's find what f prime of x is first. So f prime of x is 3x squared. So f prime of 2 would be 3 times 2 squared, which is 12. F inverse of 8. Well, if f of 2 is 8, then f inverse of 8 must be 2. That's what they do. They swap coordinates. Let's find f inverse. Oh, we can see that here. Here's f inverse. The cube root of 8 is 2. Let's find what f inverse prime of x is. Well, f inverse prime of x would be, this is x to the 1/3, so it's 1/3 x to the negative 2/3. So what is f inverse prime of 8? Well, that's 1/3 8 to the negative 2/3, which is 1 over 3 times 8 to the 2/3. The cube root of 8, let's do that first. The cube root of 8 is 2, and 2 squared is 4, and 4 times 3 is 12. So what's the relationship that we see between C and E? Well, you know what? I really should say B and E. B and E. How's that? B and E. So the relationship that we see is that the derivative is 1 over this function's value at f prime of 2. So, oh, I see. I wanted you to think about B, C, and E. So you can see this relationship that f inverse of 8 is 2, and f prime of 2 is 12, and f inverse prime of 8 is 1 over 12. So there's this relationship between these values. And that relationship is this: that the derivative of an inverse function denoted f inverse prime of x is equal to 1 over f prime of f inverse of x. Let's find out why. Well, we know that f of f inverse of x, if they are indeed inverses, they have to cancel each other out. So for example, if I had a function 3 times x, its inverse would be x divided by 3. They have to be opposites of each other. So this would cancel out and give me simply x. That's what f of f inverse does. Let's take the derivative of each side. Well, if I take the derivative of each side, I'll just write it over here, because that's what that's going to be something I can do with the chain rule. So that would be f prime of the inside stays the same. That's the derivative of that. Now I got to multiply by the derivative of the inside. And we usually write that like this. And there's like a whole bunch of parentheses. Sometimes I get lazy and I just write f to the negative 1 prime. So that's it. I took the outside was f prime and the inside stayed the same. Then I multiplied by the derivative of f prime. But what's the derivative of the right-hand side? The derivative of the right-hand side is 1. But now I can divide both sides and solve for f inverse prime of x by dividing by this fella right here. And I get 1 over f prime of f inverse of x. And that is the formula that we were trying to show is true. So it's really a very simple application of the chain rule that lets us prove that that in fact must be true. All right, so let's practice. F of 3 is 5. F prime of 3 is 7/2. What is f inverse prime of 5? Well, f inverse of 5 is what? Well, if f of 3 is 5, then f inverse of 5 is 3 because they reverse each other. And f inverse prime of 5 must equal 1 over f prime of f inverse of 5. F inverse of 5 we said was 3, so it must be 1 over f prime of 3. But we know f prime of 3 is 7/2, so it's 1 over 7/2. And what does 1 over a fraction do? Just flips it 2/7. So this derivative must be 2/7. All right, let's do another problem. I want to find f inverse prime of 2. This is a popular kind of style problem that you'll see on the AP exam. There's no way that I can algebraically solve this for the inverse. It turns out that its function actually has an inverse. It passes the horizontal line test. You can graph it and see, but you're not going to be able to at least easily algebraically solve this. So we have to use our formulas. Well, we know that f inverse prime of 2 is equal to 1 over f prime of f inverse of 2. So maybe we can figure out what f inverse of 2 is. Well, usually it's going to be a pretty small number you can try out. So let's try f of 0. What is f of 0? Well, f of 0 is a negative 1, so that's not right. But let's try f of 1. F of 1 is 1, plus 2 is 3, minus 1 is 2. So just from simple guess and check, and it's usually like 0, 1, 2, something like that. Just by simple plugging and checking, we see that f of 1 is 2. That tells me that f inverse of 2 must be 1. So this is 1 over f prime of 1. Well, how am I going to get f prime of 1? Well, that's not hard. I just have to find the derivative of f, which is 3x squared plus 2. So f prime of 1 is equal to 3 plus 2, which is 5. So this must be equal to 1/5. Okay, let's try another example problem. I want to find g inverse prime of 2. We could probably find g inverse fairly easily, but let's see if we can't just use our formula. G inverse prime of 2 must be equal to 1 over g prime of g inverse of 2. Well, g inverse of 2, we need to find that. Well, if you put in a 1 for x, I think you can see that's not going to be it, right? That'd be like the square root of 2. But if you put in not 2, but 3, you'll get the square root of 4, which is 2. So it tells me that g of 3 is 2, which means g inverse of 2 must be 3. So this is 1 over g prime of 3. Let's find what g prime is. Well, g prime of x, this is x plus 1 to the 1/2, is 1/2 x plus 1 to the negative 1/2. So g prime of 3 is 1/2 times 4 to the negative 1/2, which means 1 over 2 times 4 to the positive 1/2. And 4 to the 1/2 is the square root of 4 is 2, so this is 1 over 4. So this derivative is 1 over 4. But 1 over a fraction just flips it, making it 4. All right. Let's try the next one. Cosine. F of x equals cosine from 0 to pi. Find f prime inverse of root 3 over 2. Well, we know that on the interval from 0 to pi, cosine is positive in the first quadrant, which is 0 to pi over 2. So it's going to be pi over 6. F of pi over 6, the cosine of pi over 6 is root 3 over 2. So f inverse prime of root 3 over 2 is equal to 1 over f prime of f inverse of root 3 over 2. That's our formula. And we just discussed that we know that f of pi over 6 is root 3 over 2. So f inverse of root 3 over 2 must be pi over 6. So this is really 1 over f prime of pi over 6. Well, we got to find what f prime is. Well, f prime of x, remember when you take a derivative of a co, it's negative, is negative sine of x. So f prime of pi over 6 is what I got to find now. That's negative sine pi over 6. The sine of pi over 6 is 1/2. So this is equal to 1 over negative 1/2. And 1 over a fraction just flips it, so it's negative 2. And that is all for that lesson. So not too bad, right? Just another formula to remember. Let's write it down again together. F inverse prime of x is equal to 1 over f prime of f inverse of x. And I'll see you in the next lesson.